Are you faced with the challenge of taking over a legacy system? Or are you in the middle of the decision of taking over an old, creepy system or building a new one from the ground up? Is it question like,
to be or not to be?
No, idiots! To be or not to be, that is the question!
I'm gonna show you how my team and I tackled this situation. I will talk more about technical point of view, but to be sure, there are many important tasks to do besides technical ones. For example, manage suitable contracts between customer and contractor, set a balanced level of service level agreement, and much more. Particularly, the project is about onboarding to the enormous corporate company with strict security standards and taking over the entire ecosystem of applications forming a complex and critical system. Let's deep dive into the typical initial state of the system and processes. Initial state, architecture and code review. Applications and services. There are typically many applications and services, sometimes developed by different contractor or different team without the possibility to reach them. Another thing, so buggy. Every latest version of the application is a disaster. Fixed on the one side, broken in the other side. Technology mix very often is used the right or probably not tool for the job. Then you will have problems with various tools and technologies in your toolbox. Some of them can be outdated and not supported. Manual deployment. Many legacy systems are deployed manually or partially manually. Manual testing. Everything can rise and fall on testers. Most of the systems are not covered by automated tests. Inappropriate code quality, technical design and architecture. This is a widespread topic for many books. You can check my video about this topic. The link is in the description below. Performance issues. Bad performance and buggy state of application is typically the main reason for switching vendors.
They're not very good. You're fired. Fired!
Not meeting standards. Classical examples are REST APIs and web services that are not compliant with standards. And now let's briefly talk about the biggest issues and problems. Each deployment generates a new problems. Change in one part of the system can affect another part of the system. Dev teams delivers different functionalities than what the customer requires. Almost every change has a negative impact on the performance and business.
HD03.
H.
D03.
D.
Sometimes user must use backup system like Microsoft Word in case of system unavailability, and zero trust between the customer and the contractor, and much more. Okay, we just recapped the initial state and the biggest issues of the system and processes. And now it's time to embark. I've divided the entire journey into multiple steps, or better to say phases. Let's dive in. Phase number 1. Onboarding. If you are in the situation of taking over a project from a new customer, you will most likely have to use their enterprise technology stack. I'm talking about access to company systems like VPN, project management, CI/CD, documents, knowledge base, and so on and so on and so on. Access to current environments, applications and servers, where the applications are running. Raw study of the customer's business, applications, architecture and code, analyzing the local application and databases development environment and development processes, if they exist. Evaluation of the current approach for versioning database structure and functionalities. The expectation is
do it in the same way as source code.
Review the status of deployment of all systems, databases and environments. Check the state of monitoring systems like Elasticstack, Azure Application Insight, New Relic, and so on. Validation of the environments for unit, integration and UI tests. It sounds like an easy task, right? Especially accessing to the company's existing systems. But trust me, if your customer is a big corporate client, you can wait weeks or even months to gain access. Phase number 2, takeover. I will show you one of the approaches that is suitable for less formal organizations. In more formal companies, it's probably better to use any of the enterprise architecture framework like TOGAF. This phase has 3 stages. Familiarization. This stage can be done simultaneously by multiple roles, and that is who and what. Source code. Familiarization with the source code is done by lead or senior developers. The aim of this task is to evaluate the quality and complexity of the source code, dependencies, the state of packages, and more. You can use tools like SonarQube, right? Architecture. Architects typically study existing diagrams in the best case, but it's quite typical to have nothing from your technical ancestors. Then you have to draw architecture diagrams from scratch in cooperation with developers who help you with discovering dependencies among services. For diagrams, I recommend tools with a catalog of components rather than just drawing tools. You are able to reuse components in other diagrams or views by reference. For example, applications like Spark System Enterprise Architect or Archie. It's also very useful to write as much information as possible to the diagram's elements, like the type of programming language, version of the framework, and so on. Another thing are business processes. Analysts do their job by studying available documentation, talking with domain experts on the customer side, and filling in missing part of the knowledge base. Tools that come to mind are Atlassian Confluence, Microsoft SharePoint, and a bunch of others. CI/CD. The DevOps team's mission is to evaluate the existing CI/CD system. The goal is to automate everything as much as possible. And if there is none, then they have to suggest a system that is the best for fulfilling all requirements. There are plenty of DevOps systems like Microsoft Azure DevOps, GitHub, Jenkins, and more. Let's continue. Environments, applications, servers, third-party systems. It was mentioned earlier, but it's really important to know what the current state is and simultaneously start planning the best, most reliable and productive future state. Migration. Sometimes it's not possible to use servers, data centers or cloud providers as they are, and it's necessary to migrate the entire system to a different host. Migrating the whole ecosystem is definitely not an easy task and has to be properly considered. I will go through it quickly because this deserves its own library. There are typically these stages in the migration strategy. Plan. What, where and when. Preparation. Creation of repeatable, idempotent scripts. Tools, environments, CI/CD pipelines, third-party services, and so on. Execution. Repeatable execution strategy and automation. Validation. Acceptance tests. And finally, deployment proof. Taking over a system is mostly accompanied by rush, uncertainty, and lost trust in all contractors generally. Because of that, it's important proof the ability to get code, do some very minor changes like adjusting some titles, metadata, and so on, and roll up through all environments. Okay, let's try again and describe this stage more formally. Preparation. CI/CD pipelines and environments have to be prepared for automated deployments. Application performance monitoring must be configured to increase transparency and observability of the system. Execution. The first empty release. Validation. Acceptance tests are done by customer. And finally, celebration. Just kidding.
She's mine.
But wait, no, it's important to get some reward and motivate your team. The journey is too long and full of traps.
I once read these
filled with traps. Oh, Velma, don't be silly. That only happens in movies.
Congratulations, we did it! The second phase, and probably the most critical, is successfully completed. We are hopefully and slowly gaining our customers' trust back. And now it's time to move to the next chapter of our journey. Phase number 3, stabilization and optimization. It's time to prove that the new contractor or team is a real game changer. However, the current situation is not good because the system is in a very bad state. We have to realize that we are in the same situation as the previous team. The situation is even worse because we are not the authors of an existing ecosystem and code. Everything here is new to us. What shall we do?
To be or not to be, that is the question!
Optimization of the biggest bottlenecks. One of the most important things is the observability of the running system. You have to install and set up tools for monitoring the host environments, such as application servers, Kubernetes clusters, containers, and applications as well. Application monitoring results are part of the strategy for revealing performance issues. Source code validation/fix. You have to find the biggest issues in the code. Issues such as security, performance, quality, and bugs. There are a bunch of tools like SonarQube that can help you find code smells and let you set the different rules for the new and the legacy code. You have to prepare yourself for a very long journey to reach the expected code quality.
13 months to the day since Gandalf sent us on our long journey.
Automated test before fixing the code. Testing and automation is another very interesting and comprehensive topic. For today we have to settle for just the basics. Create tests before fixing the code. I prefer integration tests because they are close to the real usage of the applications. Sooner or later, we will find out that the previous disciplines are the backbone of the stabilization and optimization strategy. Let's define it. Continuous monitoring and optimization strategy. Here are the action steps. Monitoring, evaluation, automated test, fix, deployment, validation. It looks like this is the end of this journey, right?
The end of our journey is nigh.
But on the contrary, this is just the beginning.
Finished? Just beginning.
The last phase is continuous and it can be really endless, but the result is a tired, sad and probably very angry team. After all, who wants to live in a messy world without great expectations?
What are you reading?
Great expectations.
Is it any good?
It's not all I hoped for.
Phase number 4, modernization phase. The goal of this phase is the continuous rewriting of the entire system with a minimal impact on the current business and users. Typically, the big bang approach to system rewriting is not possible. There are 3 stages. Stage number 1, strangler fig pattern for your APIs. I've created a comprehensive video about the modernization of the application and the strangler fig pattern. Please check the video link in the description below. In this video, we will briefly go through this topic. The strangler fig pattern implementation strategy can be summarized into the following steps. Creation of a new API with proper architecture. Strangler fig pattern implementation, system and reverse proxy configuration, empty deployment and validation. Next stage, new features/continuous rewriting. Implementation of new features and legacy system overwriting, or better said, strangulating.
Manual strangulation.
And the final stage, happy outcome. There are 2 possible happy outcomes. The legacy system is completely decommissioned. or the legacy system contains only necessary and stable features. As I mentioned, the fourth phase is completely covered in my previous video, where this topic is explained in the great detail. Just check it out. And that's it. We went through the process of taking over a complex system. There are many possible approaches to manage this situation. We just picked one from the real world.
You think there's popcorn and beanbags in the real world? There's not. The real world is full of meanness and shit.